Done? Others also have completed? All right. Let us start with the derivation. See, there are 3 steps. Please open up the videos. So there are 3 steps whenever you have this parallelogram laws derivation. First step is the geometrical construction. Geometrical construction means you know how a parallelogram looks like. So a complete parallelogram would be formed and you will construct the rest of the sides which are remaining. All right. Rest of the sides which are left, that you will be constructing. Fine. And then you will construct the diagonal, which will represent the parallelograms resultant. Fine. So what all things you will construct? In geometrical construction, adjacent sides are already mentioned. You will complete the parallelogram. See, this is the parallelogram. So first step, what we'll do is, we will complete this parallelogram. Fine. And then what we'll do, we will see where our resultant is forming. So we will check, this is the diagonal of the parallelogram. Here the resultant would be forming. So this is a B vector, this is B vector, this is A vector, this is point O. So let's name this something then, QST. Let's name it like this. So this is our parallelogram. So first step done, we have our parallelogram constructed. Now for the derivation purpose, just for this derivation purpose, what we'll do, we'll construct a perpendicular from this side. This angle is theta, a perpendicular has been constructed. Fine, this is the perpendicular. Let's say this is point N. Now class, this OT is what? OT is the vector B. OQ is the vector A, right? OT, OQ. And then this QS. Look, this QS is parallel to this side, OT. So QS is also equal to vector B, right? And ST is parallel to this vector. So ST will be equal to A. Fine. And OS, just last the diagonal, OS is equal to the resultant. All the things we have mentioned. There has to be an angle. And what is this angle? The angle is taken between both the vectors A and B. This is angle theta. Fine. So first step was geometrical construction. Now we'll calculate the magnitude step 2. Come to step 2. You can write down all these things later. Now theta is what? Theta is the angle between both the vectors. Vector 1 and vector 2, that is vector A and vector B, both have the angle present. Fine. They'll be forming an angle like this, both the vectors. And here you will be having the diagonal. So theta is the angle between two vectors. Now come to its magnitudes calculation. Look, this is what? This is just this part. This triangle and this perpendicular triangle. I have just drawn it separately. Look at this. Now, if you know, we can apply here Pythagoras theorem. So our OS, see, this is hypotenuse. SN, this is the perpendicular. And ON, this is the base. Fine. So we can say OS. OS is the hypotenuse. So this is equal to ON square under root ON square plus SN square. This is square, but we are taking the square on this side, opposite side. Tell me, this point is clear to all of you? Yes? Jobita, Sabiha, Shaima, Zainab, is it clear till here? Others also at least give a thumbs up. Okay, fine. So this is OS. Now what we can do, we can split this ON. ON can be written as OQ plus QN. So OS can be written as OQ plus QN whole square. Fine. OQ plus QN whole square plus this is equal to SN. which was already there, Sn square. All right. Now let's see some more calculation parts. Now let us just focus on this triangle only. Only this triangle. For the calculation purpose, we'll just focus on this triangle. This is a smaller triangle which we have drawn, SNQ. Now this is our theta. This is the hypotenuse. Here we have the perpendicular. Here is the QN, that is the base. Class, if in this, what is this triangle? QNS. In triangle QNS, if I take cos theta, what would be the cos theta in this triangle? Yes, Shaima? Cos theta in this triangle. Value of cos theta. Shaima, can you answer? Shaima. Okay, Zainab is answered. Value of cos theta, not Zainab. I'm not asking the angle in terms of all these sides.
Ma'am, QN by SQ.
QN by SQ, right. QN divided by QS, correct. Adjacent by hypotenuse, yes, that is right. But in terms of this, okay. Now this is QN. Now C class. If I want to write QN's value from here, I can write QN is equal to QS. What is QS? QS is the B vector. So B vector cos theta. Can we write it like this? QN, this is equal to QN is equal to B cos theta. Fine. So what all equations do we have right now? Let us at least see the equations that we are having. One was the main equation. This is our first equation. This will now become our second equation. Now let's come to this triangle once again. In this triangle QNS, Sabiha, you answer. Sabiha, you tell me what would be sine theta then? Sabiha? Sn by Qn. Sine theta. SQ. Correct. Sn by SQ, right. Now look. So sine theta correctly, Sabiha has also answered and Zainab has also answered. This was NS, this side divided by this QS. Now we'll have one more equation. If I write the value of NS from here, what is QS? Again, we have QS as B. So I'll get B sine theta. This is BS, B sine theta. This is the third. Now we'll put these two equations. Now see what we have received. We had OS is equal to OQ plus QN. Now OQ was nothing. QN was nothing. Right? These were just terms which were cut in between. We already knew what was SN. So what we'll do, SN's value we have obtained. Right? We have obtained a value of QN also. And OQ, we know it was already A. So this was A. This we have obtained B cos theta. This we have obtained B sin theta. We can put all these values in this equations. Put 2, 3 in 1. Right. So if we put all these three values, the resultant would be C. First one was OQ. That was vector A. Plus. Second was B cos theta. So this whole square plus b sine theta whole square. This. Now you just have to solve this for the calculation part. Tell me, class, before this is clear to you? How have we substituted the values till here? Clear to all of you? Others? Shaima, Sabiha, Jovita, clear? Shaima and Jovita, fine till here? Yes, Jovita, you're not present? Okay. So, see, now what we'll do, we'll just open up the bracket. Okay, Jovita, fine, good. Any doubts if you have, please ask and get it clarified. So a plus b cos square theta plus b sine square theta. Now you know this identity, a plus b whole square. This is a square plus b square plus 2ab. So what we'll do, this is a square. This is our b. b square cos square theta plus 2ab. That is 2ab cos theta plus b square sine square theta. Now, class, look at this. B square cos theta, here b square sine theta. Can I take b square common from this? I can take b square common from here. So, look, this is a square. If I take b square common from here, I'll be left with cos square theta plus sine square theta plus 2ab cos theta. Right? Now, class, can anyone tell me the value of this? What is the value of this? 1. Very good, Zainab. See, cos square theta plus sine square theta, this is equal to 1. So finally, if this is equal to 1, what will be the resultant? The resultant would be equal to under root a square plus b square plus 2ab cos theta. So this is the main equation for the resultant of a parallelogram. Now look, what is this? This is the magnitude of the resultant, not the complete answer. It's the magnitude of resultant. It's the magnitude of the resultant. What is this? This is our first vector. What is this? This is our second vector. So this is first vector, this is second vector, this is angle between the vectors. Angle between the two vectors. Now, for the direction part, I'll tell you later, but tell me till here. Magnitude of the resultant, first vector, second vector, angle between them. This is r is equal to under root a square plus b square plus 2ab. This is very important, very, very important. But without the direction, it is incomplete. But you first write this down, otherwise it will be a lot of portion for you to understand. Right? Start writing from here. Anything you have not understood, please ask and clarify. No, magnitude come in modulus. Magnitude would come in modulus only because it is getting squared. A square, B square. So even if it is negative, -1 square would give you 1. -2 square would give you 4, even if it is negative. but it's not necessary. It's not necessary. There is direction associated, but magnitude is not necessary to come in modulus and be positive all the time. You can have any value, whatever you are getting, because sometimes even after all those things, you have cos theta is 180 degree or some values which are negative. So that can be allowed here. Okay, Zainab.
Ma'am, can you scroll up? Done, ma'am. Ma'am, can you scroll up? Done, ma'am.
See class, let's come to the direction part now. See, we will consider angle beta between resultant and the vector A. So where is our resultant and where is the vector A? Look here class. This angle class. This is our angle beta. Beta is the angle between the resultant and the vector A. Fine. So this is the beta that we'll be considering for the direction. Always you will have to mark it. Now this was our condition which we were taking. Now we will take tan beta here. So tan beta will be equal to Sn by On. Again, we can write On as combination of OQ plus Qn. Now class, just write down the meanings of every term. Tan beta. What is Sn? Sn is the perpendicular we had calculated b sine theta. OQ is the vector A plus Qn is b cos theta, which we have calculated. That's it. This is the formula for the direction. So magnitude plus direction, this is the complete derivation. Derivation, I'm doing it first so that at least you have the derivation and formula of parallelogram law in your mind. Before starting with the question, we'll first discuss unit vectors we will discuss, I cap, j cap, so that you have the basics of that also. Then we'll discuss some questions from parallelogram law. But questions from parallelogram law, we'll discuss it in the next class only. But unit vectors, I'll start today. Write this quickly. See, unit vectors are those vectors that have the magnitude as 1. This is how we represent a vector. You put a cap over the head of the vector. That shows that this is a unit vector. Now, this is how you write the unit vector. Here you can see the force is 1 Newton, magnitude is 1. Velocity is 1 meter per second along x-axis. Magnitude is 1. So these are unit vectors. This is the normal vector. This is a complete vector's representation. This is a vector. And this is a unit vector. When you have to calculate and this is the magnitude. This is the magnitude, this is the vector, and this is the unit vector. So when you have to calculate the unit vector, you write down the exact vector and you divide it by its magnitude. This is the formula. This is easy, you can just write it. But this part, I'll tell you how to calculate the magnitude of any vector. One more thing, class. There are certain universal unit vectors. You have 3 axes, x-axis, y-axis, z-axis, right? I cap is along x-axis. J cap is along y-axis. And k cap is the unit vector along z-axis. I cap, j cap, k cap. Unit vector along x-axis, unit vector along y-axis, unit vector along z-axis. So for positive x-axis, we write plus I cap. For negative x-axis, we write minus I cap. Likewise, for negative z-axis, for positive z-axis, for positive y-axis, negative y-axis, this is how we write this. Okay, this is the origin. Oh, so this is how we write the unit vectors. Let's see the applications of it, but first write it down. Then I'll tell you this Cartesian form. Write down this first. Fine class. Now we'll complete this unit vector. This is a small topic tomorrow, and we'll discuss the questions of parallelogram law. Not tomorrow, sorry, in the next class now. So vectors will be completed by the next week. Next week we'll give time to vectors, and then one more week for projectile motion. Then this will be. All right, class. You all can leave now. Thank you so much.
Thank you, ma'am. Bye.
Thank you.